Hey folks, I wanted to give you a run through of sizing lintels in the building code. So first we're going to get into a little bit of background information to help you understand lintels a little bit better, and then we're going to get into sizing them. So of course lintels are those beams above our windows that help distribute the weight from overhead to the sides onto our cripple studs or our trimmer studs and prevent our windows from just being crushed or preventing our doors from not being able to open because they're getting crushed as well. So things that affect the size of our lintels would be how many floors is the lintel carrying. So we know that our building has to transfer weight from all the way at the top, all the way into the ground below. So through the roof, through the walls, through the foundation, through the footings, into the ground, right? So if our lintel is on the first floor and it's carrying 2 floors above it and the roof, it's going to be different than if the lintel is just carrying the roof. So also, something that affects the size of the lintel is how far does it have to span. So we know that from when we're sizing floor beams, the more weight we're carrying, we can't span quite as far, right? So we have to put more posts under our floor beams. So the rough opening from cripple stud to cripple stud is how far that lintel has to span. So that's going to matter. Obviously, a 2-foot window versus a 6-foot window is going to make a big difference. Now, another thing that matters is the snow load in your city. So in the building code, they have this section in the first binder, climatic and seismic information. And in that section of the code, it talks about temperatures, snow, it talks about rain intensity, it talks about moisture, drying, it talks about wind, all these things in the, having to do with your building. But in these charts below, you see table C2, you can see for different cities, they show some good information. So they show the heating degree days, so how much, basically designers would be able to design how big of a furnace or how many heaters a building would need based on that. You can see, different cities have different amounts. So Beaten River here is colder than it is in, Campbell River, all right? So they would have to have more heating or possibly more insulation to deal with that. What we're going to be focused on is here, snow load. So here we have our snow load, and then here we have our rain load on top of that. We have to use a formula to combine the snow and the rain because obviously wet snow is much heavier than dry snow. So dry, cold, like fluffy snow is a lot heavier, is a lot lighter than that rain-soaked snow. Another thing that affects the size of our lintel is whether or not our walls have sheathing on it. So structural sheathing is looked at as plywood or OSB greater than 9.5 millimeters thickness. So that's 3/8 of an inch, which we're always going to use that. We have 1/2 inch plywood or 7/16 OSB, most of the time on our exterior. So why that matters is because the building code allows us to increase our span by 15% if we have structural sheathing. Now that makes sense because imagine if we had the load over a window and we took a sheet of plywood and we kind of locked that window in and you nailed it off. So you nailed it off to the cripple studs, the lintel, all the upper jack studs, the top plate, some of these side studs. You're creating kind of a load transfer system. Yes, you're going to end up, cutting this out, but it's still acting like a team. It's kind of like the bridging in our floor, how that helps distribute the weight over a greater area. So this is great because it's something that we normally do, and it actually increases the strength of that lintel above the door or window. So you can see here the load paths. We have the weight from above. It's pressing down on our upper jack studs, and half the weight goes to the left, half the weight goes to the right. It's going to be sitting on our cripple studs on the side of the opening. Our king studs are helping tie that whole opening top to bottom. And then if you look here, our windowsill and our lower jack studs are really not supporting any weight, right? You see there's no arrows here because all they have to support is the weight of the window itself, which compared to a roof full of snow is basically nothing. So we're not super concerned about the windowsill because it's really not carrying a lot of weight. Yeah, we got to still build it if we have a window, but imagine if you wanted to change this window opening into a door. That'd be really easy to do. You just need to remove that whole section, and now you have a door, right? As long as, of course, as long as you have enough height. But yeah, changing a window to a door can be an easy thing if you got enough width and height and everything. But if you had to change the width of a window, that makes things drastically harder because we need to move all of our support, and it's just more work. We have to do a lot more work to get that to work. Now, if we were to look at the position of the lintel in the wall, so this lintel, the purple one down here versus the orange one up here. Now, obviously, the purple one is carrying more weight because it's carrying the weight of this floor, and anybody dancing or having fun up here, playing piano, whatever heavy things you have on that floor, plus the weight of the roof. As opposed to the orange lintel, it's just carrying the roof. Now, just might be a lot if we have tons and tons of snow built up on the roof. But that purple lintel here down on the first floor has to carry the floor, all the weight above, all the live loads on that floor, plus the roof as well. Okay? So we need to consider that. So in theory, you could have a lintel down here at the bottom here. So if we had a pressure-treated wood foundation, you could have a lintel in a pressure-treated wood foundation. This is when we have a foundation that's not concrete. It's actually made out of 2x6 or 2x8 pressure-treated wood. So if let's say you had a walkout basement, you could have 1, 2, 3 floors plus the roof load at the top. So that lintel would be carrying a lot of weight. And so the span on that lintel would be drastically different than the span up here on this upper floor just carrying the roof. Now, if we were to look at how lintels are positioned, sometimes you have to actually cut out the top plates like you're seeing here to get enough headroom for our lintel to fit. So for doors, for interior doors, we normally frame that 82 inches off the floor to the underside of the lintel. For exterior doors, we normally frame that to 83.5 inches off the floor. And if you had a big 2x12 and a wall that wasn't very tall, you might have to force that lintel up higher to make room for that. So what this is showing us is that if you're doing that, you need to put a steel plate on either side here or a wooden plate on either side to help brace off that section. So if we were to look at that from a top-down view, imagine you had your king stud here, and your lintel was here in the middle, and then you had the wind blowing against that building. Basically, you have hinging points here because that top plate's not running continuously across. So normally we're framing this with double top plate across and it's no problem, but that is something to consider if you happen to break the top plate. Also, we might have non-load-bearing walls, non-load-bearing partitions on the inside, or potentially non-load-bearing exterior walls. Depends on how you frame your roof and how things are loaded. But here you can see we just have like a 2x4 or a 2x6 on the flat. Probably we would have some upper jack studs here. But yeah, if it's not carrying weight, we don't need to put a beam in there. There's no need for that. So looking at that chart we were looking at, so what we're really focusing in on is this section here. So the snow and then the rain. And here for Burnaby, you can see it's different than in North Vancouver, right? So 2.7 versus 3 and 0.4 for rain versus 0.3 for North Vancouver. So let's look at we'll get to the formula in a second. So does snow load even matter? Well, of course. Look at how much snow is built up on this roof. Obviously, that's a lot more weight than if there was no snow on the roof. Now, unfortunately for this guy, the wind happened to cause the snow to drift, and you can see that mound is pressing down right over top of that window. And yeah, if we didn't size that properly, that window would be crushed. You'd start seeing the effects of that on the structure. And even over here, if you look at the snow buildup, on this side, pressing down on top of that garage door, that's going to be a lot of weight as well. So, of course, the snow load factor matters. Now, this is light, dry snow, fluffy snow, but if it got rained on, that would just increase. So we need to basically prepare for the worst case scenarios. Now, the formula for our snow load factor, our specified snow load, is going to be, to get our value for S, we take this snow load factor times whatever we see in the chart for the SS number here, and then we add on our rain, because the rain is going to kind of compound the weight of that snow. So the SS is the 1 in 50 year ground snow load. So how much, it's kind of on average, they're averaging it here. And the SR is the 1 in 50-year rain load. Now we're going to use the 0.55 factor here because most of the time our buildings are larger than 14 feet wide, and so we're going to use that. So for an example, let's pick Abbotsford here. If we take Abbotsford, we would go CB plus times SS plus SR. So 0.55 is our CB times 2 plus 0.3, and we get a snow load factor of 1.4. Now you might be thinking, great, now I have 1.4, what do I do with that? Well, what we're going to do is we're going to take it over to this chart. Okay, so depending on how much load we're picking up here, we're going to look. So 1.4 is too big to fit in the 1.0 column, but it does work in the 1.5 column. So Abbotsford being 1.4, we can put that in the 1.5 column. So let's say we had to pick up a 1-story plus a ceiling. We would be looking at focusing in on these numbers. So for example, a double 2x4 can span 0.88 meters, right? And a double 2x10 can span 1.88 meters. Okay, so a double, you notice how it's 2 by, we're always doubling these up at least. Okay, so these are all doubled up. So let's look at an example. Here we have a place built in Burnaby. So the house is built Burnaby where you're going to use SPF material. That's where the lintel is. So the lintel is carrying 1 story plus a roof and a ceiling. So it's carrying this floor plus the roof and the ceiling above. And for Burnaby, the SS number, the snow load factor here number is 2.7 and the rain is 0.4. So 0.55 times 2.7 plus 0.4 is 1.89. So 1.89, unfortunately for us, is too big for the 1.5. So we're going to have to jump up to the 2.0 column here. Okay, now this lintel, like we said, is going to be carrying a roof and a ceiling plus 1 story. So what we need to do then, we're getting our rough opening. Again, that's from cripple stud to cripple stud. So our rough opening, we're going to have to take these numbers and convert them into millimeters. So for example, 49 times 25.4 is equal to 1.245 meters. Well, let's put it in millimeters here. 1,245 millimeters, but if you just change that to a decimal, it becomes 1.245 meters. So now we have 1.245. We're going to look here. A double 2x4 does not work, but a double 2x6 works because this is less than 1.27. So we can get away with a double 2x6. So we'll kind of work our way through the chart like this. I'm just going to give you the measurements here. So 28 inches is 0.711 meters. So if you look, yeah, that's less than 0.89. So we can get away with a double 2x4. 68 inches times 25.4 is 1,727 millimeters, so 1.727 meters. So let's look. No 2x6, no 2x8. We're going to have to go to a double 2x10 for that big wide window there. Okay. So we have a door, an typical exterior door. We've got, ooh, I forgot to calculate this one. 38 times 25.4. We've got 965 millimeters. So 0.965. All right. And we can get away with a double 2x6 because 965 is too big for a double 2x4, unfortunately. Now 84 times 25.4 equals 2.134 meters. Okay. So 2.134, too big for a double 2x10. We got to go up to a double 2x12. So that's really kind of as simple as it gets. So as long as you have this formula down, you get your factor, your snow load factor, you figure out what column you're going to be in. Okay. Now I just want to expand on this a little bit. So if you look at the liner notes underneath this chart, so if you look at this chart underneath at the bottom, I think it's on the next page actually, you'll see this. So additional code rules. Where structural sheeting is used, lintel spans may be increased by 15%. So we're going to talk about this for a second. Structural sheeting consists of a minimum of 9.5 millimeter panels. Not a problem because we're going to be using thicker plywood or OSB than that. If the floor joists span the full width of the building without support, lintel spans must be reduced. So if you had a building that was wide and there was no intermediate beam, there was no beam running up the middle or no load-bearing wall, we have to reduce it by 15, 20, or whatever, depending on how many stories we have. I'm not going to get into that. It's just overly complicated for what we're doing. Oh, this is interesting. A single piece of 3.5-inch thick lumber can be used instead of 2 pieces. So basically, you can put a piece of lumber in that is the same size as a double 2x4 or a double 2x6. It's one solid timber. That's kind of a neat thing. Lintel spans are based on a maximum floor joist span of 4.9 and 9.8 meters. So as the building gets wider and wider, we also have to reduce the size of our or the span availability of our lintels, because they're carrying a longer floor joist or a wider roof. There's just more area being put on that lintel. And so for the most part, our lintels are going to be supported on 38 millimeters of bearing, but if the span of the lintel is greater than 3 meters, it's going to be put on 76. So basically, if your window is less than 10 feet, we can get away with a single cripple stud. If your window is larger than 10 feet, we're going to double that up, so it's going to be 2 cripple studs. And then as you get wider and wider, you have to add more cripple studs. Okay? So let's look at an example here. Let's get back to Burnaby. And here we're adding 15%. So what I just did is I took I'll go back, took the span numbers here, and I went, so 0.89. Oops. I just learned how to write today, folks. 0.89 times 15%, or times 1.15, and that's going to give us a greater span, so 1.02. So by adding structural sheathing, it's actually might change. So let's see. I just changed this here to give us our width in meters already. So 49-inch here, 1.245. Let's see if we can get less than a double 2x6. We can't go double 2x4, it's too big. So it stays a double 2x6. Here, we're already happy with double 2x4. It's not going to go lower than that, so that stays the same. So here we have 68 inches, 1.727, and we had a double 2x10. So we were here in this row. We were right here. Well, 1.72 is less than 1.78. So that 2-ply 2x10 can become a 2-ply 2x8 by adding structural sheathing. So that made a big difference right there. Let's see if our door changed. So we had 0.96 before. We had 0.89 here, and so we had to go to a double 2x6, but I think you know where this is going. We can reduce that to a double 2x4 over that door. And this double 2x12, before this was smaller, and we had to go to a double 2x12, but it looks like 2.13 is less than 2.17. So we can get away with a double 2x10 there. So adding structural sheathing, increasing our spans by 15% made a difference in this example. And yeah, so it's quite helpful to know if you can do that. Now, as I've mentioned, we probably aren't going to be doing a lot of sizing of things in the building code. But if you happen to be doing a renovation, maybe you would want to do this instead of hiring an architect or an engineer and getting involved. Or if you wanted to design a small structure, a garage or something on your own, it is useful to have these charts at your hand to be able to size things. And of course, knowing that you can add structural sheathing, how that would affect it, would be helpful as well. Anyways, guys, I hope you find this helpful. Best of luck practicing sizing lintels in the building code. And this will be helpful for our shop project, where if you look at the window schedule, we'll need to figure out what size lintels we need over our windows and doors for our H4 wall framing exercise. All right, so take care, guys, and we'll see you out in the shop.